Hello students, today we are discussing a topic on laser. L- Laser stands for light amplification by stimulated emission of radiation. The theoretical basis for this laser was first given by Albert Einstein in 1917. In 1960, the first laser was developed by T.H. Mayman. And now we will see some definitions regarding this laser. Whenever the light electromagnetic radiation interacts with matter, the three processes there will be three processes taking place. The first one is a stimulated absorption or simply absorption. That means whenever we give some energy to a system, the atoms present in the ground state will be excited by making use of this supplied energy, and this is called as the absorption process. So in this diagram we are looking at you see, this is the ground state and this is the excited state. Ground state is represented by E1 and E2 is the excited state, and E2 minus E1 gives the amount of energy to be supplied to the system. And here we can give the light energy. The energy given to the system may be in the form of light, so that's why it is shown in the like a photon. So let E1 and E2 be the energies of the ground state and excited state of the atom. Suppose if a photon means light energy of energy E1 minus E2 is equal to h nu is given, that energy interacts with the atom present in the ground state. The atom gets excited from ground state to the excited state E2. This process is called as a stimulated absorption or simply the absorption. So this stimulated absorption rate depends upon the number of atoms available in the lowest energy state as well as the energy density of the photons, and stimulated absorption rate is proportional to number of atoms in the ground state, and also it is proportional to the density of the photons of the incident radiation. The second process which is going to take place whenever the electromagnetic radiation interacts with matter is the spontaneous emission. So in case of spontaneous emission, it was first postulated by Bohr, and here the atoms present in the excited state will go to the ground state spontaneously without any external stimulus. This is called as the spontaneous emission. Here again you are looking at the E1, it is the ground state, and E2 is the excited state. So you can see the atom is already in the excited state, and this comes to the ground state without the help of any external agency or force, and hence it is called as the spontaneous emission. So in this process a photon is released. The energy of that photon is equal to the energy of these two energy levels. Therefore E2 minus E1 is equal to h nu. And this spontaneous emission rate depends upon the number of atoms present in the excited state. So therefore the spontaneous emission rate is proportional to number of atoms in the excited state. Next is the third process, means whenever electromagnetic radiation interacts with the matter, the third process which is going to take place is the stimulated emission. Here in case of the stimulated emission, atoms will be excited to the higher energy states, but these atoms will not come down to the ground state without the help of an external stimulus or external energy. So stimulated emission was first postulated by Einstein. So here E1 and E2 be the energies of ground state and excited states of the atom. So energy, photon energy E1 minus E2 is equal to h nu interacts with the atom present in the ground state. So the atoms gets excited from ground state to the excited state E2. Okay, and the lifetime of the atoms in the excited state is generally of the order of 10 to the power minus 8 second. After that time they will come down to the ground state. But here what happens, the atoms which are excited to the excited to the some higher energy level, they will not come down to the ground state themselves. They need further few more energy or a stimulus to come down. So therefore we will have to supply some extra energy to make that excited atom to come down to the ground state. So in this case, therefore there will be emission of two photons. One photon is emitted because of the energy difference between these two energy levels, and another photon is the incident photon. And the very interesting point is that these two photons will be in phase. That is a very interesting phenomena, and it is very important for the lasing action. So the energy of these two emitted photons is given by, again, the difference of these two energy levels, and which is equal to h nu, where h is the Planck's constant and nu is the frequency of the radiation. Okay, so stimulated emission rate depends upon the number of atoms available in the excited state as well as the energy density of the photons. So the stimulated emission rate is proportional to number of atoms in the excited state and density of the photons. And here we can see the difference between the spontaneous and stimulated emission. So the first difference is that the spontaneous emission was postulated by Bohr, whereas the stimulated emission was postulated by Einstein. And additional photons are not required in spontaneous emission. Additional photons are required here as a stimulus for the come down of the photons. One photon is emitted in spontaneous emission, whereas in stimulated emission two photons are emitted. The emitted radiation is polymonochromatic. The emitted radiation is monochromatic. Polymonochromatic means it is having more wavelengths, and this monochromatic means the emitted radiation will have only one wavelength. That is the very important point. And the emitted radiation is incoherent in case of spontaneous emission, but here the emitted radiation is coherent. Coherent means all the photons will be in phase, and they will be having the same frequency and amplitude. The emitted radiation is less intense, whereas here the emitted radiation is high intense. The emitted radiation have less directionality, whereas here the emitted radiation have high directionality. Example for spontaneous emission: light from sodium or mercury lamp, and here light from a laser source. So these are the difference between the spontaneous emission and stimulated emission. But for the laser to be emitted, we'll have to have this stimulated emission of radiation. The stimulated emission of radiation is must for the laser emission. Thank you very much.